Good day, learners. Today we are going to discuss measure of central tendency, specifically mode of group and ungrouped data in statistics part 3. Before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be notified for my upcoming videos. Thank you.
Three, two, one, zero.
Uno, dos, tres, cuatro.
Mode: the number value observation in a dataset which appears the most number of times. If no number in the list is repeated, then there is no mode for the list. However, it is possible to have more than one mode for the same distribution of data, and that is what we call bimodal, trimodal, or multimodal. How to find the mode of ungrouped data? To find the mode of ungrouped data, find the frequency of each number value observation in the given set of dataset. Then, choose the number of value observation having highest frequency as the mode. Example: find the mode of the given dataset. Okay, the first thing that we need to do, arrange the dataset in ascending or descending order. Then the second step, determine the number that appeared the most number of times. In the given dataset, the number that appeared the most number of times is 22. Therefore, the mode of the dataset is 22. The dataset is said to be a unimodal. Example number 2. The speed of the stenographers in typing per minute are shown in the table below. Determine the mode of the speed of the stenographers. First step, arrange the dataset in ascending or descending order. Second step, determine the number that appeared the most number of times. In the given data, the number that appeared the most number of times are 115 and 112. Therefore, the mode of the dataset are 115 and 112. The dataset is said to be bimodal. Example number 3. Find the mode of the given dataset. First step, arrange the dataset in ascending or descending order. Second step, determine the number that appeared the most number of times. And it is shown in the first step that there is no number in the data list is repeated. Therefore, there is no mode in the data list. Mode of group data. To find the mode of the group data, we use the formula. Mode is equal to exact lower limit plus delta sub 1 divided by delta sub 1 plus delta sub 2 times the class size interval, where L is the exact lower limit of the interval containing the modal class. Delta sub 1 is the difference between the frequency of the modal class and frequency above it. Delta sub 2, difference between frequency of the model class and the frequency below it. The I is the class size interval. Example number 1. The record of 21 people in a 100-meter race is summarized in the given frequency table. Find the median of the given data in the frequency distribution. This is our frequency distribution, where the first column is our class interval in time per seconds, and the second column is our frequency. Since we are going to find out the mode of the group data, we have to identify first the interval with highest frequency, and that is the interval 61 to 65, with highest frequency 8. This is our row considered as model class. Afterwards, we have to identify the exact limit of the class interval of our model class. So if we have 61 to 65, by subtracting zero point 0.5 to our lower limit and by adding zero point 0.5 to our upper limit of our class interval, then the exact limit of class interval will be 60.5 to 65.5. Then we can say our exact lower limit L is 60.5. And let us now identify now our I using the formula I is equal to upper limit minus lower limit plus 1. If we are going to take the interval 51 to 55, our upper limit is 55 and our lower limit is 51. Then I is equal to 55 minus 51 plus 1. Then I is equal to 5. After, we have to identify the frequency above the model class to get now the delta sub 1 using the formula the frequency of the model class minus the frequency above the model class. Then we have our frequency of model class is 8 and the frequency above the model class is 7. Then delta sub 1 is equal to 1. Then after, we have to identify the frequency below the model class, and that is 4. To compute now delta sub 2, which is the frequency of the model class minus the frequency below the model class, which is 8 minus 4, then our delta sub 2 is equal to 4. So we can now compute our mode, which is the exact lower limit plus delta sub 1 divided by delta sub 1 plus delta sub 2 times the class size interval. Substituting now the values, so we have 60.5 plus 1 divided by 1 plus 4 times 5. Then, let us simplify further. We have 60.5 plus 1 times 5 divided by 5, which is equal to 60.5 plus 1. Then the mode is 61.5. Example number 2. 30 students in the class took a statistics test. The results are recorded in the frequency distribution table. As shown in the table below, find the mode of the data distribution. This is our frequency distribution table. Shows that the first column is our class interval, which is the scores of the students, and the second column is our frequency. First, we have to identify the class interval with highest frequency, and that is the class interval 40 to 49, having a frequency of 9. And this row will be our model class. And since we already identified our model class, let us identify the class interval of the model class and get the exact limit of the class interval by subtracting 0.5 in the lower limit and by adding 0.5 in the upper limit. Then the exact limit of the class interval of our model class is 39.5 minus 49.5. After, we are going to take 39.5 as our L. And let us now compute now for our class size interval. If we are going to take class interval 70 to 79, our upper limit is 79 and our lower limit is 70. So let us now substitute to our formula. I is equal to 79 minus 70 plus 1 is equal to I is 10. And the next thing we need to do is to identify the frequency above the model class, and that is 7. To compute now our delta 1, which is frequency of the model class minus the frequency above the model class, and that is 9 minus 7, our delta 1 is equal to 2. And after we have to identify the frequency below the model class, and that is 2. To compute now our delta 2, which is frequency of the model class minus the frequency below the model class, and that is 9 minus 2 is equal to 7, and our delta 2 is 7. To compute now the mode, let us use the formula. Mode is equal to exact lower limit plus delta sub 1 divided by delta sub 1 plus delta sub 2 times the class size interval. Substituting now the values, we have 39.5 plus 2 divided by 2 plus 7 times 10. As we are going to simplify, 39.5 plus 2 times 10 divided by 9. So simplifying further, we have 39.5 plus 20 divided by 9 is equal to 39.5 plus 2.22. Then we can say our mode is 41.72. And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.